Hey everyone, Norman here with the McWane Science Center, back again with another SciSpark. As a mathematician, I love to study forces and all the different ways that they interact with objects. There are a lot of different forces in the universe. I'm sure you could name a few yourself. I mean, a familiar force is gravity. But what if I told you that sometimes what we observe as a force isn't actually there at all? Alright, first things first, we need to know exactly what a force is. When you think of a force, you probably imagine some sort of push or pull. Well, Sir Isaac Newton told us that a force is some kind of influence on an object that causes its movement to change if it isn't balanced in some way. For example, these dominoes are still because the force of their weight from gravity is being supported by the force of the table pushing back up against them. However, if I were to apply a force by pushing the top of one domino, gravity works to rebalance the system by pulling all of the dominoes down until their weight is firmly supported by the table again. But there are way more forces than just the pull of gravity or the push of a finger. First, we have friction, the force that acts between two objects pushing against each other, like my domino lying on this bubble wrap, not falling off until it's tilted just too much. There's also the elastic restoring force, which is the force that wants to restore an object to its original shape after it has been stretched or compressed. This one is the reason why rubber bands are able to snap back when pulled, or why springs are able to bounce. A related force is the tension force. This is the force that tries to hold an object together when it gets pulled on. This is also why when you try to hang something from a rope, it doesn't get stretched out forever. Then there's centrifugal force, the force that pushes an object outward when it is spinning in a circle. Kind of like this bucket when I swing it up and the water doesn't spill. This is the same force that medical labs use to separate certain chemicals, and it's the force that you might experience on a merry-go-round when you're spinning really fast and have to hold on to the center bars to keep from flying off. Except, centrifugal force doesn't exist. Hear me out. What we think of as the centrifugal force isn't actually there when you observe the system from the outside. While it's true you might feel like you're being pushed off the spinning merry-go-round, or the water in that bucket might feel pushed down to the bottom at all times, there isn't actually a force at play like in the other examples. These are just examples of objects experiencing their inertia in full swing. Instead, the forces at play are centripetal, or inward-facing forces. Usually, this is just tension toward the center, keeping the object spinning. But since objects in motion don't like to change their motion, not even their direction of motion, the force pulling them toward the center is constantly keeping them from flying off the edge of the circle, which is where that feeling of pushing out comes from. But we see this in a force called the Coriolis effect as well. This is when an object looks like it's curving while it moves, like if you throw a ball from a spinning merry-go-round, but in reality, it's moving in a straight line, which you could see if you were watching from the still ground. This effect can even be seen in how winds move across the spinning Earth, contributing to weird effects like storms spinning different directions depending on which hemisphere you're in. Even gravity could be considered a fictitious force. I know. How could I say such a thing? We all experience gravity, right? Yeah, well, one of Einstein's biggest contributions to the world of physics was his realization that getting pulled down by gravity is no different than getting pushed up by a surface. If you think that sounds confusing, just take a look at the math involved in this general relativity. Of course, I could go into how all the other forces I mentioned earlier are really just examples of atomic interactions caused by the electromagnetic force interacting between electrons to push each other apart, or protons and electrons pulling each other together. But I think that's as good a place as any to end today's SciSpark. Thanks for watching, and if you liked what you saw, be sure to leave a like and subscribe to the channel for more content. Until next time.